Good morning, children. So today we are going to discuss about the concept of aim for. What is that concept of that aim for? Pole and polar. Pole and polar. See, first, now here we can draw a circle. Now we can draw a circle. Now on this circle, suppose here take one point P outside of the point P. Now here we can draw two chords as like so. This is AB and this is CD. So here P and AB comma CD are two chords. Okay, na? They are meet at the point P after extensing. Okay, na? So they are meet at the point P. Now here I can take the point P is x1 y1. Here I can take the point P is x1 y1. So here AB is the chord. AB is the chord. Now here I can draw. Here I can draw a pair of tangents at AB. At AB. See, as like see suppose. Now this is one tangent and this is another tangent. This is the pair of tangents. Yes or no? These are the pair of tangents for AB chord. Now here CD is another chord. CD is another chord. So for that point C and for that point D, now you can draw a pair of tangents. You can draw a pair of tangents. Okay. Now here see this point you can be taken as Q1. Now this point you can be taken as Q2. Now we can join this Q1 Q2. Now we can join this Q1 and Q2. This now join Q1 and Q2. This line is called the polar. This line is called the polar. Here P is called pole. P is called pole. This is called the polar. Suppose not only these two chords. Suppose you can take another chord. See. Suppose you can take another chord. Now here we can draw the tangents. Here we can draw the tangents. Suppose this is the point, this is also point. Here we can draw the pair of tangents. That point is also lies on that polar only. Okay, na? I hope all are understood this one. Suppose here you can take another. Suppose this is the chord. Now here is one point, here is another point. Suppose at that points you can draw the tangents. The point of intersection of these tangents are lies on the polar. Lies on the polar. Okay, na? So I hope all are understood this one, pole and polar. Now suppose you can draw the lines as like this. So from P you can draw the pair of tangents. From P you can draw the pair of tangents. See, now this is the point of contacts. So that point of contacts are also lies on this polar. Okay, suppose now this point, okay, this point you can be named as X and this point you can be named it as Y. You know that XY is called, this XY is called chord of contact. already in the previous exercise, previous aim we have discussed nana. See, suppose from outside we can take a point P. This is a pair of tangents. So these we join these point of contacts. Now they can recognize the xy. Now that xy here, it is called what? Chord of contact. Chord of contact. Okay, Anna? So here chord of contact is only the this polar. The chord of contact only the polar with respect to point P. With respect to point P. Okay, Anna? So you know that what is the equation of chord of contact? The equation of the chord of contact is S1 is equal to 0. Similarly, equation of polar, equation of polar, equation of the polar with respect to point P, x1 y1 is S1 is equal to 0. Is S1 is equal to 0. Keep it in mind. So the equation of the polar and the equation of chord of contact both are the same. S1 is equal to 0. For a circle, S is equal to 0. For suppose here see, this is a circle. Okay. Now I can take the chords as like this. This is the chord AB. Okay. Now here you can take another chord as like this. This is CD. Okay. Now you can draw the pair of tangents of AB and CD. See, first of all you can draw a pair of tangents of that CD. To CD. So now here this is one point. Now you can draw the pair of tangents of AB. Pair of tangents of AB. Now we can join these 2 points. Now we can join these 2 points. This is equation of polar. This is the equation of the polar with respect to the point. Here it is this is the point P, and here the intersection point of chords, the intersection points of the chords lies inside of the circle, and here P lies inside. P lies inside, then polar lies outside. The polar lies outside. Understood, Nana? So here in this example, here P is lies outside. Here P is lies outside. Then the polar is lies inside of the circle. Next, the third case. Suppose P lies on the circle. P lies on the circle. P lies on the circle. Then what about the polar? See, suppose the circle, suppose you can take the point P. So the polar of P. Now here take 2 chords as like this is one chord and this is another chord. These are the 2 chords AB and CD. The point of the 2 chords are intersecting at the point P. That P is lies on the circle. Now you can draw the tangents. So here this is the polar, అంటే polar P lies on the circle, then polar passes through P only. So that is tangent of P. And when P lies on the circle, then the polar is its tangent only, tangent at P. Okay, na? I hope all are understood this one, polar concept. Now see, this is the equation, this is the circle. Now here I can take a point P outside of the circle. Now here you can draw a pair of tangents. Now this point and this point we can join this one. This is called the polar. This is only the polar. We don't know this polar equation. Suppose we assume that this polar equation is Lx plus My plus N is equal to 0. This is the polar equation. We don't know, but we assume that the polar equation is Lx plus My plus N is equal to 0. Now here the point P is x1 y1. The circle equation can be taken as S is x square plus y square is equal to r square. Okay, na? So now what is the equation of polar? Equation of the polar is S1 is equal to 0. So therefore xx1 plus y1 minus r square is equal to 0 is the equation of the polar. But here we can say that the equation of the polar is Lx plus My plus N is equal to 0. These both are identical. So now we can solve these both equations. So we can get here x coefficient is x1, here x coefficient is L. Therefore we can be written it as x1 by L is equal to, next here y coefficient is y1, in this one y coefficient is M is equal to minus r square by N. You know, in pair of linear equations, any two equations are the coincident, then this is the condition. It's a1 by a2, a1 by b1 is equal to a2 by b2 is equal to that is a1 by a2, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Okay, na? Now you can solve these two equations. We can get x1 is equal to minus L r square by N. Now solving these two equations, we can get y1 is equal to minus M r square by N. So here x1 y1 is what, nana? Pole. So what is here pole? That is minus L r square by N comma minus M r square by N. This is the pole. Okay, the polar equation is like as Lx plus My plus N is equal to 0, then its pole is minus Lr square by N comma minus Mr square by N. Now we are going to discuss about that conjugate points. See, for suppose you can take one circle. Okay, now here I can take one point P. So here we can be taking it as the P point is x1 y1. Now the polar of P lies inside the circle. We know that the polar of P lies inside the circle. So this is the polar of P. This is polar of P. Okay, now we can take a we can take here on the P, okay na, on the P we can consider a line, we can consider a line as like this. So, okay, suppose or otherwise you can take